Hi Calc AB, this is page 9. So this is no calculator. Here we have a function f and it's defined on the closed interval from -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be the function defined by g equal to the integral from -3 to x of f of t dt. Now before we go on, it's important to know how f and g are related. G prime equals f and g double prime equals f prime. If you know that about your problem, then it's important to write it somewhere. And I will be writing it in my reasonings, but if you write it here next to the graph, then you can get credit for that. The reason that that's true is because this integral is equal to the antiderivative up high minus the antiderivative down low. When you take this derivative, you're differentiating each of these terms. And the derivative of the antiderivative is right back at the function. And this derivative is 0 because it's a number, so it's not changing at all. So that's the connection there, and then therefore g double prime is equal to f prime. So that's an important thing to note as you move forward. And the integral is also from -3 to x, and so that's starting right here. Part A says find g of 3. So g of 3 is the integral from -3 to 3 of f of t dt. And looking back up here, that just represents the net area from -3 all the way to 3. So I see 3 triangular regions, or you could consider it to be 2. Take a second and come up with what those areas will be. So I get the areas to be 6, 4, and 1, but because the integral is the net change in area, you've got positive area and negative area, so that makes 9 for our answer. Part B, on what open intervals contained in -5 to 4 is the graph of g both increasing and concave down? Give a reason. So anytime you are talking about a function increasing, you look at its first derivative, and if the function is increasing, the first derivative will be positive. That translates into the slope being positive. Concave down translates into the second derivative being less than 0. So that, because they gave us a graph of f, I'm going to make 2 sign charts. Showing how all of this breaks down. So from -5 to 4, because they give us an interval to consider. The next step is to figure out what values go into your sign chart, and then the positives and negatives that are associated. Remember that what goes in a sign chart is either where this number equals 0 or does not exist. At the first sign chart where g prime equals f, that will equal 0 at the x-intercepts in f. And there's not a place where it doesn't exist. So we're only going to consider -3 and +2. So in our g prime equals f sign chart, we'll put -3 and +2. And then we just have to consider that f is positive for all of these values. And then f is negative for these values here. I filled that in my sign chart. So now moving on to the second sign chart, this is g double prime equals f prime. So that represents the slopes of f. So we need to consider when the slopes of f are either 0 or they don't exist. So the slopes are never 0. You never see like a nice curve to a maximum or to a minimum. So there are 2 places where f prime wouldn't exist, and those are happening at corners. So we'll have a corner at -3 and another corner at 0. But if you look at the slopes, if you zoom into the slopes, these slopes here are all negative, and then they're positive, and then they are negative again. So I'm going to update my sign chart. There's my updated sign chart. And now the question is, on what open intervals contained in -5 to 4 is the graph of G both increasing and concave down? So again, that's G prime being positive and G double prime being negative at exactly the same time. I see two places, G prime positive and G double prime negative, G prime positive and G double prime negative. So our job is to communicate that to the College Board. Remember that they will not ever grade your sign chart, so it's almost like this doesn't ever exist. And we still do it though, because it really helps us understand the problem. We say G is increasing and concave down on this interval. And the because is, I think, the most important part, because it explains how you know your answer. G prime equals F is greater than 0, and G double prime equals F prime is less than 0 on the exact same interval. When in doubt, use parentheses. And the thing that I really want to highlight is this connection. They gave you a graph of F, and you, as the student, shows your learning by saying G prime equals F and G double prime equals F prime in your response. Part C. The function h is defined by h equals g over 5x. Find h prime of 3. So we need the derivative of this quotient. So you remember quotient rule. Low d high minus high d low, draw the line, and square below. Make your substitution. Simplify where you can. Remember that g of 3 was something that you've already found in part A, so that was 9. Just as a side note for the AP test, if you use your part A answer, that would be okay, and they would look at this work to determine if you understood this idea. So you wouldn't get marked down on that twice. So whatever you had for part A is okay to use here, even if you're unsure. G prime of 3 is the same thing as F of 3 because of that connection that we've made. So going back up here, F of 3 is equal to -2. And you can leave your answer just like that because it's a no calculator part. You're allowed to leave your answer in terms of add, subtract, multiply, and divide. Part D, the function p is defined by this function. Find the slope of the line tangent to the graph of p at the point where x equals -1. The key to that question is that you only need the slope of the line tangent. You don't actually need to find the tangent line. You just need the slope of the line tangent, which translates into the derivative. So this is a question about chain rule because we have a function within another function, and that other function is f. So when you take the derivative of the outside, you also have to multiply by the derivative of the inside, and that will be 2x minus 1. We want the derivative at -1, So we make a substitution. Simplify where we can. F prime of 2, we'll go all the way back up here. F prime of 2 is the slope of this region right here. So you can count lines going down like tick marks. This is 1, 2, 3, 4 over 2. So down 4 over 2. The slope is -2. And our final answer is 6. Bye.